Okay. Um, Let me have more students, just 1 minute more. Mm, Okay, let me start uh, to continue my lecture. Okay, I already talked about this slide. Okay, line supports also come in a variety of types, each suitable for different application and conditions. Common options include wooden pools, which are simple and cost-effective for shorter spans. Steel pools offering greater strength and durability. Reinforced concrete pools known for their long life and resistance to environmental factors, and lattice towers, which provide exceptional mechanical strength for long distance and high voltage lines. And selecting the appropriate type of line support depends on factors such as load requirements, span length, environmental conditions, and economic considerations. Okay, the selection of supporting structure for overhead lines also depend on several important factors. The line span determines the mechanical strength required, while the cross-sectional area of conductors influences the load support must be bear. Line voltage plays a role in defining the required clearance and insulation considerations. So, and cost also is a key factor, as both installation and maintenance expenses must be considered. And finally, local conditions, including climate, terrain, and environmental stress, can also affect the durability and suitability of different types of supports for our case. Balancing these factors ensures safe, reliable, and economical overline construction. So the first one type is wooden pools are suitable for overhead lines with moderate conductor cross-sectional areas and relatively short spans of up to 50 meters. They offer several advantages. They are inexpensive and readily available, and naturally provide electrical insulation. And because of these properties, wooden pools are widely used in distribution networks, particularly in rural areas where cost effectiveness and ease of installations are key considerations. Okay, despite their advantages, wooden pools have several limitations. They tend to rot below ground level, which can lead to foundation failure, and they generally have a shorter lifespan of around 20 to 25 years. And wooden poles are not suitable for voltages above 20 kilovolt due to limited insulation and mechanical strength. Additionally, they require regular inspection and maintenance to ensure safety and reliability. Okay, this slide illustrates two common configurations of wooden utility poles used in power distribution systems. On the left, we see a single wooden pool structure, while on the right, a double pool arrangement reinforced with steel bracing is presented for added stability. And key components are highlighted, including the insulators, which support and electrically isolated the conductors, the cross arms, which extend horizontally to hold the insulators and maintain proper spacing between lines, and the pools, which serves as the primary vertical support. In the double pool design, steel bracing is added to enhance structural strengths and resist external forces such as wind or heavy loads. So these structures can make very strong structures for any of this environmental impact. So in overall, this slide emphasizes how different pole configurations are selected based on mechanical strength requirements and environmental conditions in electrical distribution networks. Okay, this slide introduces steel pools as an alternative to wooden pools in power distribution networks. So steel pools are increasingly preferred due to their superior performance characteristics. So they offer greater mechanical strength, allowing them to withstand heavier loads and harsher environmental conditions. Additionally, steel pools have a longer service life compared to wooden pools, reducing the need for frequent replacement and maintenance. Another important advantage is their ability to support longer spans between pools, which can reduce the total number of pools required in a network. Overall, steel pools provide a more durable and efficient solution for modern electrical infrastructure. Okay, this slide highlights the practical application and maintenance requirements of steel pools in distribution system. These pools are commonly used in urban areas where higher load demands and space constraints require strong and reliable support structures. So to ensure durability and extend their service life, steel pools must be properly protected against corrosions, and this is typically achieved through galvanization or by applying protection paint coatings. And such treatments help prevent rust and environmental damage, so making steel pools a dependable choice for city-based electrical distribution networks. Okay, this slide introduced reinforced concrete poles, which have become increasingly popular as supports in power distribution lines. So reinforced concrete poles combine concrete with internal steel reinforcement, providing excellent durability and structural performance. Compared to steel pools, they offer even greater mechanical strength, making them highly resistant to bending and external forces. They also have a longer service life as they are less susceptible to corrosion and environmental damage. Especially corrosion is very important. So additionally, reinforced concrete pools allow for longer spans between supports, improving the efficiency of line design and reducing the number of pools required. So overall, reinforced concrete pools are a robust and cost-effective